Good day. For this particular lecture video, we'll be talking about thermochemistry, most particularly heat, work, and sign conventions. The following would be the lesson objectives. Number one is to describe how energy is transferred through heat and work. Number two would be to describe how work is done by the system and on the system. And then number three is to solve problems involving the first law of thermodynamics. First law of thermodynamics, we'll be talking about heat, work, and sign conventions. For the first law of thermodynamics, we are actually concerned with energy being possibly transferred into and out of a system through heat and work. Take note, energy can be transferred into and out of a system by means of heat and work. Nata-transfer po into at palabas ng system ang enerhiya sa pamamagitan ng formang heat at work. Since we are more interested in the energy changes taking place in a system, we can express the first law of thermodynamics using the following formula. This is change in energy is equal to heat. Heat is represented by Q plus work represented by W. So change in energy is equal to heat plus work. Now, what about sign conventions? Now, whenever we would be calculating the change in internal energy means change in E. So internal energy or change in E are the same. In calculating the change in internal energy of a system, we must also consider the sign conventions for heat and work. Now, what are sign conventions? Now, sign conventions are just certain rules or just conventions that we need to follow based on the processes how work or heat is being done or processed within a system. Now, let us look at the following signs when work is done by the system on the surrounding. So when work is done by the system, take note of the keyword by the system, the sign or the numerical sign for work would be negative. The sign for work would be negative as well if the process is expansion. So it means that when the work is done by the system and then the process is maybe expanding, the numerical sign for work is negative. Now the sign for work would be positive if the work done is on the system or the process is compression. The sign would be positive if the work is done on the system, by the surrounding, or the process is compression. Now, the sign for heat is positive if heat is absorbed by the system or the process is endothermic. Take note, the definition of an endothermic reaction is, as the prefix suggests, endo, that means absorption of heat. So whenever heat is absorbed by the system, the sign for heat is positive. And now, the sign for heat is negative if heat is absorbed by the surrounding, or in other words, heat is released. Exothermic. As the prefix suggests, exo, that means release of heat. So whenever heat is released by the system, released by the system, or in other translation, absorbed by the surrounding from the system, heat will be negative, exothermic. So this will be the sign conventions that you need to follow before you proceed with the calculation. Ibig sabihin lang po ng sign convention, bago po tayo dumiretso sa pag-compute, pagka-calculate, alamin muna kung tama ang mga sign, mga numerical sign. Kung positive ba o naka-negative ang work at heat. Okay? So these will be your convention or rules to follow for work and heat signs. Now let's have a sample problem. When gasoline burns in a car engine, the heat released causes the products carbon dioxide and water to expand, which pushes the pistons outward. Excess heat is removed by the car's cooling system. If the expanding gases do 451 joules of work on the pistons and the system loses 325 joules to the surroundings as heat, calculate the change in energy or the internal energy characterized by change in E in joules. So let's have sample problem number 1. So sample problem number 1, I already indicated the given required in equation, but let us understand how the following came about. So again, take note of the sign conventions for heat and work before we proceed. Okay, so let us look at this one, 325 joules and 451 joules of work. According to the problem, the system loses 325 joules of heat. Nag-release, exothermic. Ang system po ay nawalan, nag-lose. Now, if the system lost heat, exothermic, instead of having it as 325, according to the sign convention, exothermic, heat will be negative. So negative 325 ang ating gagamitin. Next, 451 joule. The gases expanded. Ayan no? If the gas expanded and do 451 joules of work, what will be the sign? So again, expansion. Work. Expansion. The system do work by the system. Expansion by the system work, negative sign. Kaya po instead of writing 451 joules, it should be negative 451. Okay? So that is how we identify the sign conventions by means of the understanding and analyzing the problem. So it mentions expanding gases. So yung work instead of 451 dahil nag-expand, expansion negative, negative 451. Tapos yung heat naman, ang sabi, heat is lost, release heat. So instead of writing it as 325, we can write it as negative 325. Kasi exothermic nawalan ng heat ang system. So this will be our given, negative 325 and negative 451. Okay, and then our requirement is change in E with the equation change in E is equal to Q plus W. So since the sign conventions are already followed, nasundan na po ang mga sign, we may now proceed with the substitution. Our heat is negative 325 joules plus the quantity negative 451 joules. Okay, so change in E. Input this on the calculator. Okay, so this will be negative 325 plus negative 451. So our answer would be negative 776 joules. This will be the final answer. Ganun lang po. Very easy. As long as we follow the sign conventions for heat and work. Okay. So from the PowerPoint presentation, I also have here the same solution. Adding negative 325 and negative 451, we have negative 776 joules. Sample problem number 2. What is the amount of heat transferred when the internal energy of the system decreased by 72 joules and 44 joules of work was done on the system? Sample problem number 2. So once again, I already provided here the given required equation, but before we proceed, let us understand first how the following given required equation came about. Okay, so take note of the sign conventions for work. 44 joules of work was done on the system. So look at the given. Done on the system. Work done on the system, according to sign convention, work should be positive. So we shall use 44 joules. Okay. Next, internal energy of the system. According to the problem, the internal energy decreased by 72 joule. What does that mean? Pag sinabi pong decreased, ibig sabihin ang magiging sign po ng internal energy natin or change in E ay negative. O ba't naging negative bigla? Kasi ayan po, binanggit ng problem. Pag sinabi pong decreased by 72, decrease, bumaba. So that would indicate a negative sign. So negative 72 joule. Okay, so now that our given are now okay in terms of sign conventions, we may now proceed with the required. The requirement of the problem is the amount of heat, or Q, and then our equation is E is equal, change in E is equal to Q plus W. Now, since Q is missing, we need to derive an equation for Q, so that would be Q, or heat, is equal to change in E minus W, work. So we just need to transpose work to the other side of the equation so that we may have heat isolated. Okay, so now substitute. So this will be negative 72 joule minus 44 joule for work. Okay, so input this now on calculator. So this will be negative 72 plus, or rather, minus 44 joule. We have negative 116 heat. Okay, so that will be the answer for this problem. Okay, ganun lang po. Madali lang siya. Linear lang ang equation. Kailangan lang natin ma-assure na sumusunod ang mga given sa ating sign convention. So from the problem, I have here the same given required equation, and then the same answer as well, being negative 116 joules. Next part of the discussion will be focusing now on work. Now, what about work? In thermodynamics, work can be viewed as a means of energy transfer. Sa usaping thermodynamics po, ang work ay pwedeng gamitin bilang pamamaraan para matransfer ang energy. Okay, so we can transfer energy by means of work. Work is defined as directed energy change resulting from a process. Okay, an example of a process which causes an energy change or energy transfer is the expansion and compression of gases. So natatransfer po ang energy sa pamamagitan ng pag-expand o pag-compress ng gases. So pamamagitan po ng pag-expand at compress ng gases na ipapakita po ang work. In thermochemistry, these processes are examples of mechanical work. So sa tuwing po nag-expand, nagko-compress ng gases, ang tawag po doon ay mechanical work. So sa pamamagitan ng mechanical work, natatransfer natin ang enerhiya. Okay? Always remember, work done by the system is expansion, the sign would be negative, while work done on the system or compression is positive. Okay, so just like a quick review from the sign conventions. Expansion is negative, compression is positive. Okay, so expansion, okay, expansion is negative, compression is positive sign for work, respectively. So look at this from this image. Look at my cursor. The piston expanded. So whenever the system does work, expansion, that's negative sign. And then when the piston compresses, work is done on the system. The system is this gas. Ayan po, yung system po dito na sinasabi, yung focus is itong gases, itong may color, itong green and then yung purple. So when compression or work is done on the system, so kino-compress itong gases, compression, positive. Habang ito naman, itong gas, yung gas ay nag-expand, yung kulay green. So yung sistema, yung gas ang gumagawa ng trabaho. Expansion, work done by the system. Negative sign. Now, how do we compute for work? The following equation shows you how mechanical work in gases is calculated. Work is equal to negative external pressure times change in volume. For P is external pressure, and then change in V is final volume minus initial volume. Take note that the unit for work must be expressed in joules. Kasi po, kapag kinumpute po natin itong work is equal to negative P times change in V, ang resulting unit ay liter atmosphere. Dapat ang work naka-joules. So after po natin isolve ito, after natin isolve tong negative P times change in V, i-convert pa natin yung sagot. Gagawin natin joule sa pamamagitan ng conversion factor na 1 liter atmosphere is equal to 101.3 joules. Example. Okay, so let me read the example here. Okay. A sample of nitrogen gas expands in volume from 1.60 liters to 5.40 liters at constant temperature. What is the work done in joules if the gas against a constant pressure of 3.70 atmosphere? So the given required equation is already provided. Your given is initial volume is 1.60, final volume is 5.40, and then your external pressure is 3.70 atmosphere. According to the problem, we need to solve for work in the unit joule, so the final answer should be in unit joules. Since the final answer should be in the unit joule, we need to consider the conversion factor as such, that is 1 liter atmosphere is equal to 101.3 joules. So let's solve. So solution, work is equal to negative pressure. Pressure is 3.70 atmosphere multiplied by change in volume. So volume would be 5.40 joules minus 1.60 joules. Okay. So let's simplify the following answer. So negative 3.70 atmosphere, and then simplify the difference. So 5.40 minus 1.60, that's 3.80, 3.80 joules. Okay, and then we multiply them now. So negative 3.70 times 3.80. So we have here 14.06 or 14.1, negative 14.1. This is, I'm sorry, this is supposed to be liters. Sorry, I have input unit joule for volume. My bad. This is supposed to be liters. See, this one liters. I have copied it wrong. So 4.1 liter atmosphere. Now, since this is not yet the final answer, the unit for work should be in unit joule. We need to derive this further or convert. So this will be 101.3 joule all over 1 liter atmosphere, according to this particular conversion factor. Cancel, we have now unit joule. Okay, so now this is negative 4.1, negative 14.1. This is times 101.3 all over 1. We have negative 1428, but we only need 3 significant figures, so I'll be getting negative 1,430. So negative 1,430 joules is the work for this problem. Okay. From the PowerPoint presentation, I have the same given required equation. The solution is also the same. We have here 3.80 volume. And then we have 14.1 liter atmosphere initially, just like what I've done. 14.1 liter atmosphere din ang kanyang sagot. And then further on, since we need work in joules, we need to convert it. Hence, we have negative 1,430 joules per conversion factor. Okay. Next example, sample problem number 4. So let's read the problem once again. A gas is compressed from a volume, sorry for that typographical error. A gas is compressed from a volume of 1.25 liter to a volume of 0.240 liters against a constant pressure of 1.10 atmosphere. What is the change in internal energy of the system if it loses 175 joules of heat to the surrounding? Initial volume is 1.25. Let me explain how the given came about. Final volume is 0.240 liters. Your external pressure is 1.10 atmosphere. And then what about this 175 joules of heat? Okay? There is an inclusion of heat. And since it mentioned loses, nawalan, exothermic, ang sistema daw ay nawalan o nag-release, nag-lose ng energy. So according to sign convention, whenever the system exothermically reacted or nawalan, nag-lose ng heat, it will be negative. Ayan, no, negative 175 instead of only 175. Sign convention, merong heat. Okay? Now, according to the problem, we need to compute for change in internal energy. Change in internal energy is change in E. So, ibig sabihin po, kailangan natin gamitin ito ang main equation natin. Change in E is equal to Q plus W. Diba? Ito yung una na. Ito yung first of thermodynamics, Q plus W. However, meron kang Q. Pero wala kang given na W. Ayun, no? Ito ang main equation. Ang pinapahanap ay change in E. Requirement change in E. So your equation would be change in E is equal to Q plus W. Check kung binigay lahat ng factor. May Q. Meron ka bang W? Wala. Walang given na work. So that means, kailangan mo muna gawin itong unang equation. So magka-connect. Para ma-solve ang internal energy, Q plus W, wala kang work. So kailangan mong i-solve muna yung value ng work by means of negative P times change in V. So magka-connect po ang dalawang equation na yan sa pagsosolve. So inahin natin yung equation number 1. Okay, so solution. So work is equal to negative 1.10 atmosphere times change in V, 0.240 liters minus 1.25 liters. Okay, so simplify again, 1.10 atmosphere, so negative 2.40. I mean 0.240 rather, minus 1.25, negative 1.01. Negative 1.01 liters. Okay, so V, final volume is, it's 0.240 minus 1.25. Okay, so the resulting unit would be liter atmosphere. So we just need to multiply this on the calculator. So negative 1.10 times negative 1.01. Okay, so we have 1.111, so 3 sig fig, positive 1.11. 1.11. Okay, so now this is work. Is 1.11. So proceed with step number 2. Since we need change in energy, itutuloy po natin ang solving. Okay, so 1.11. Plus, tama rin po. Positive ang sign 1.11. Bakit? Tignan. Compression. Ano ba ang sign ng compression according to sign convention? So let us look at here. Ayan, no, compression, positive. Compression, positive. And our problem mentions that the gas is compressed. And look at our answer for work. 1.11. Positive. So tama. So we may now proceed with making sure that liter atmosphere is appropriate. Okay, so dapat ito pong liter atmosphere ay gawing joule. So kailangan pa natin yan i-convert. Okay? Hindi po pwede agad dumiretso sa number 2 kasi dapat ito ay joule. Alalahanin natin ang work dapat ay naka-joule unit. So 101.3 joules all over 1 liter atmosphere. Saan ito galing? Ito po yung conversion factor for liter atmosphere and joules. Ito. Okay? So we need to convert work into unit joule. Kaya natin yan i-convert muna. So cancel. Okay, so what will be now the unit for work? So 1.11 times 101.3 all over 1. 3 sig fig, we have 112. 112 joules. So now that we have unit joules, ayan akma joules ang ating work. Naka-joules din ang heat. So pwede na natin to isolve. So heat is negative 175 joules plus 112 joules of work. Okay, so the remaining unit or the resulting unit would be joules. Input this in the calculator. Negative 175, sorry about that, it's negative. Negative 175 plus 112. You have negative 63 internal energy in joules. This is our final answer. Okay. From the PowerPoint presentation, we also have the same given, required, and equation. We need to start by computing for work. Since internal energy is required, the equation for internal energy is Q plus W. We have Q, but we do not have factor work. So we need to compute for work from scratch using equation number 1. So hence we have this. Okay, so negative 1.01, we started with that one, remember, and a negative 1.01. And then we multiply it, we have 1.11 liter atmosphere. Now, since liter atmosphere is not an appropriate unit for joules, or rather for work, we need to convert it into unit joule by means of the conversion factor. We have 112. Tulad lang din po dito, 112 ang work. At tama, positive ang unit kasi compression ang sign convention for this particular unit. Then, we proceed now with Q plus W. We have negative 63 joules of internal energy. Okay, so same solution. Okay, so as you recall, these are the equations involved in the first law of thermodynamics. Now, number 1, internal energy or change in internal energy is equal to Q plus W or heat plus work. And suppose that work would be missing. If ever work is missing in this particular factor, solve for work using work is equal to negative external pressure times change in volume, wherein change in volume is equal to final volume minus initial volume. Take note as well to convert liter atmosphere into joules using this particular conversion factor. Right? I hope the following lesson objectives were achieved. Describe how energy is transferred through heat and work. Describe how work is done by the system and on the system, and at the same time solve problems involving the first law of thermodynamics. Okay, so once again, I hope you learned a thing or two about thermochemistry, particularly on the first law of thermodynamics on heat, work, and also the sign convention. Okay, once again, thank you, and I hope you learned a thing or two. Have a great day.